Okay, we continue discuss the planar kinematics of two bodies. Okay. So let's say we have this scenario. You look at example 5. So you have this mechanism, rod ABC, point A with a sliding plate here. A is limited to y-axis movement. B also have one mechanism here, lock it to only can move x direction. Okay. So this will be like your nowadays your big main gate that can fold, right? So okay, so you have A moving in this direction, B you don't know, and you have an angle of 45, distance of B to C 0.1, A to B is 0.2, total length is 0.3 meter. So you have a link guided by two blocks A and B move in a fixed slot. If the velocity of A is 2 meters per second downward, determine the velocity of B at the instant of 45 degrees. So before you solve this kind of question, you try to imagine what is the motion of the object. You want to find velocity of B here. So when A move down, this one will twist. Move down, this one will not twist, but B will move to the right at a certain speed. Okay. But C here, if the question extends, C here will become rotation already. C here will be a circular motion. But this question stop at B. B is the linear equation, right? But this one, you can see this one is actually is rotation, translation and rotation at the same time. Okay. So how to solve? You draw kinematic diagram. So AB restricted to only one slot and the velocity of A is given. So B will sure move to the right. So A is moving downward. B must be horizontal to the right. Motion cause the link to rotate clockwise. Anti-clockwise. So anti-clockwise is a rotation omega, angular velocity and angular acceleration omega and alpha in this way. So same, you link with these two equations, V equal to omega R. A, you have tangent and normal direction. AT equal to alpha R, AN equal to omega square R. We'll use right hand rules to determine the direction. So this way is when you rotate this one is clockwise, right? You use right hand rules. This one rotate anti-clockwise. So your thumb point out. So it's perpendicular the plane of the motion. So it's your thumb pointing out, right? This one move this way. So you basically, when you look at the rod, right? Look at the rod, omega is anti-clockwise, V is moving down, and you have A and B here, A and B. So A and B, you are focusing on B. So your right RB stroke A, direction of vector pointing to the B, B, VB this way, A this way. So basically you can move your vector here to here. So you can combine the vector. So you have RB, RA to the distance here and here. Okay. So I show you all there are two solutions. There are two solutions. One is using vector analysis, whereas I think most of you don't like this method. When you use vector analysis, you need to call ij and k component, or you use VB equal to VA plus omega cross R stroke B. Okay, this one, what is this? This is, okay, you want to find this diagram. So you want to focus on B, is A. You want to focus on B. So you write this is, and the direction tell you this is R B from A. So you want to find velocity at B. So you write VB equal to, is the same. I start with VB stroke A equal to VB minus VA. So since I'm finding B, I rearrange this one. VA plus VB stroke A. Then I further expand. What is V? V is omega R. So in this case, I write omega cross R B stroke A. Okay. So I look at the diagram and I know that the direction is pointing A to B. The question asked me about B. So I know my R is B stroke A. My focus is B, right? My focus is B. So I know that when I differentiate R, I can get velocity. So I change straight away, I change R to V. I write VB stroke A, and I know that I can translate or transfer my slash into negative here. Then after I have this relationship, I focus on the question. The question asked me about VB. So I stay VB, I pull VA to the left-hand side, I get this one. Then I link to what I learned with angular and scalar vector. So this one, VB stroke A equal to omega cross R. So this is a vector analysis. So what you do, VB is moving to the right. So you write V. This one should be big I. VBI, because it's moved to the X direction, is I direction. So VBI, it should not be small, typo error here, equal VA. VA move down is J. Go up, okay, plus omega. You know that this one rotate anti-clockwise with your right hand rules is pointing outside, so positive. Outside the screen is positive. So positive K cross. What is your RB stroke A? This one is RB stroke A. RB stroke A is this direction. RB stroke A is going down, but you can split into two directions. One is X direction and Y direction. And again, the angle is given there. This is the angle that you focus on, right? So you draw the trigonometry, right? So this side, this and this will be cos theta. So RB stroke A cos theta. Okay, this one, this one and this one will be sine. Sorry, yeah, okay. So if you're weak in trigonometry practice, okay, so from there, your x is sine theta I, your y is going down, is negative j. Okay, then you do the cross products. This one you remain. K multiplied by I, you will get j. K cross I, you will get j. K cross j, you will get I. And you're equaling the I and j. I and I you put together. I and I you put together. VBI equal to 0.2 omega cos 45I. Then your J, you have J here, don't have J. So 0. 0J equal to J, just pull. This one also you pull. So here you have two equations. You can solve what is your omega. This one maybe you cannot solve, but this one you can solve because 0, constant value. This one press calculator, you can find omega. Omega equal to 14.1 radian per second anti-clockwise. So once you find omega, you can solve. So once you find omega, you can find VB. VB equal to omega R. Okay. 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 VB. This one you substitute here, you get your VB. Okay. Second one, I think most of you like this one. So you're using scalar method. So you draw the diagram. You transfer the motion into this diagram. So A to B, and you know that uh, B is moving this way, but because this is rotating, so your VB stroke A is in this direction, right? And the omega is anticlockwise, 45. So what you do, your VB equal to VA, VA is going down, plus omega 2, whereas 2 is here. Omega 2 is your VB stroke A. So this is the vector direction. Your VB move to the left, VA move down. VB stroke A is 45 degree towards this direction. Okay. So you split into X and Y direction. You do X direction first. X direction VB, this one is in Y, so becomes 0. This one you split into X direction, so omega 0.2 cos 45. Then you do for Y direction, this one is not Y, so 0. This one Y negative 2. This one Y is sine 45. So you'll get the same analysis for omega. Once you get omega, substitute back here, you still get the same answer. Okay. So just don't confuse VB direction and VB stroke A direction. Okay. You might ask, sir, how do I know the direction of this one? Okay. This is VB from A. For VB from A, if you stand here, you 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 stand here and you move down, you'll be seeing B move to your left. Okay. So it depends either you want to do scalar or vector analysis. So this is another one. A rotation body give you the omega, rotate with the R radius, and velocity of conveyor is 0.6 meters per second. It gives you positive direction X, positive direction of Y. So cylinder roll without slipping on the surface of conveyor. If we see the word without slipping means velocity you can transfer. Velocity inside the diagram you can transfer to any parts of the bodies. So it is moving at 6 meters per second. So if this one move, you can transfer this VC to this point here. Determine velocity at A. Cylinder at clockwise angular velocity. So clockwise is go inside. So find A. So if you use vector analysis, so vector analysis, you draw this diagram, omega, A and B, B velocity at here, following the conveyor speed. This one move here, you transfer this speed to here. So VB equal to 0.6. A, you know the position and the relative distance A to A from B, A from B arrowhead point here, and VA is in this direction with the theta. Okay. So you can again write VA equal to VB plus omega cross RB. So you change this one to velocity, then you shift the slash into negative, flip around, like what I write on the whiteboard there. This is a scalar vector method. So VA, you have an angle, so you have X and Y direction. So that's why you see I and J in the solution. Then this one, VB is given. VB only have one direction to X. So that's why you see 0.6i. Omega is given. Omega, Y negative, you go inside the screen, is negative. Okay, go outside screen positive, go inside screen negative. Cross RB, this one is from B to A, is pointing to A. So you can split this vector, go up and go to the left. So go to the left is negative Y. Your arrow pointing to the left, but positive to the right. Then your Y is going up. You do the cross products. K I, negative, positive, cancel. So K I become J, K J become I. Then you match the I together. You do the I together. You get what is your VA. Then VAX. You continue matching the J together. You get what is your VY. VAX, VAY is two direction. You need to find the resultant. Square this one, square root, and you're able to find the direction. Okay. You square root it, and the direction you use the tangent equation. Right, inverse tangent, you get to find the answer. Okay, scalar. You look at the diagram here. This is your homework lah. Go and see this in your revision. Go and see this PowerPoint slides. It's the same. Okay. Now we look at instantaneous center at zero velocity. We call it IC, instantaneous center. So let's say we have a particles rigid body rotating in the anti-clockwise direction. Okay, anti-clockwise direction. So right hand rules, this one go inside, right? Axis go inside, and you have a fixed point of your interest. So when this one rotate, A will move in the circular motion with the tangent direction. This is your VA. And let's say we have a reference point given in the green color. So this one, let's say we have an instantaneous center. We call it IC. So location of IC is that velocity of the point on the body is always perpendicular to the relative position vector. So what does it mean? If you want to use this method, instantaneous center method, your velocity, you draw your velocity vector, then you use your ruler corner, go to the point and draw one perpendicular distance to a certain reference point. Okay, and then this one become your R, and this is the reference point. Okay, this one you can draw anywhere in the in your solution, as long as you follow the direction of your V with the corner at your ruler. Okay, you draw anywhere. The length of this one, it depends. Okay, you want it long, you make it long. You want to make it short, you make it short. Okay, but this is a vector from IC, so RA stroke IC. Okay, important for rigid body, you have to know your vector from where, especially here. From where? Okay, the rest you read. Now, what is important is relationship between velocity and angular motion. V equal to omega r. That is more important. You keep repeating. The rest is just arranging of the equation. Okay, so let's say we have 2 points. This is one body. One body have 2 points. Let's say your eye and your leg. So your eye is A, your leg is B. So when your body rotate, you will see that your eye actually moving in the circular motion. B also moving in the circular motion. So to you, this method is always easy. Go and imagine how the point A move. Point A move in a circular have tangent direction. So A, V tangent will be always tangent. You draw a tangent velocity from A. Then use your ruler. Go and find a ruler with the sharp corners. Move your ruler here, draw a line. The length is doesn't matter. Draw a line. Then you go to B. You imagine B is this B tangent direction this way. So you draw VB this way. Then again use your ruler, corner, go and match the tangent line. Go here and draw the line. The length again is doesn't matter. It's important that it's these two lines join together. Okay, as long as these two lines will join together, you will always join at one point. It won't go outside A4 paper one. Okay, you will always join at one point. So this is called IC method. And what is important beside that joining the 2 point is that the labeling of your vector. Okay, now the first step if you want to use IC method is very easy. You mark 2 points, the point of interest, then study the motion. Where's the idea? Move up, move down. We always move in tangent when it's rotate. So tangent direction velocity, tangent direction velocity. Use your ruler. Go and draw a line perpendicular to the. You go to the point A here. Draw one line. Go to point B here. Use your ruler corner. Draw one line. They will intersect one. That is your instantaneous center location. Instantaneous velocity also means at this position, this point doesn't move, right? So then you label accordingly. You someone stand here, look to A, the arrow pointing from instantaneous to A. So you label R A stroke IC from IC. A here from IC here. RB stroke IC from IC to B, like this. So your arrow always pointing from the IC point, then to the velocity. IC point to the velocity. Okay, and it by this vector, you know that this body rotate anti-clockwise. If you join this vector, you're actually seeing this move rotating in the same direction. Yeah. So this is how you do. Um, okay. So the rest is just explanation on the same steps. Let's say this phenomena. Let's say this body also you choose 2 points, right? You choose 2 points, and this one rotate this way. You pick 2 points, then you want to find the IC direction, right? So what you do? Let's say A is here. You draw on the same line. Okay. A here, B here. They mesh at the same point. So what you do? Again, you draw this rotate like that. So what you do? You draw A vector tangent. B, where does it go? This way. Then how you draw the IC things? You use your ruler, go ruler, the corner of ruler point to A, you draw one line. Corner of B, again move, draw one B. Intersect is at the center here. At this case, when A and B they join at the center, you will see they join at the center here. Okay, this is how you draw, and this is the distance between these two. This another diagram. Same approach, huh? You pick 2 points. This one rotate this direction, so same. You draw the circular motion, then find where is the tangent direction velocity for A, for B. Then A, you move your ruler, corner, move to the A position, draw one line. Move to B, draw one line. So here, the intersect will be somewhere here, right? Okay. So this is how you find it, lah. Huh? This is how you find it. It's the same. So the distance between the two IC point in this case is the D, this one plus this one. This one is RBC, RBC minus RAC is this distance. Yeah. Okay, let's practice how to find the IC location. This one actually very easy to score if this kind of question come up. So show how to determine the location of IC instantaneous center of zero velocity for member BC. This one, and the link CB. Okay. Now before you draw the IC location, you have to show what's the question target you to solve. For example, A, he asks you to target BC, right? How BC member move? BC move in this direction, but A push B down, so it will be like that, right? So point B move circular motion because of the joint here. So VB will perpendicular to AB, right? This one rotate like that one. So there's a always tangent direction of this blue circle, blue pathway here. Okay. C very direct. C is always this direction. So you draw the body, all right? You copy the body. You label BC. B, you follow the curvature of this line. You just draw tangent direction. Okay. Then you join C this way, right? Okay. So okay, the rest is you read, but what is important, you know how to draw the red arrow. Then how to draw AC. Okay, very direct. Once you draw the red arrow, use your ruler. Move your ruler end to the point. As long as you get 90 degrees, just draw. Same with C. Move your ruler, touch the point C, draw. You get 2 points here. As long as 90 degrees. This 90 degree, this 90 degree. So this is your IC point. Okay. And direction of B to C is this direction. Okay. Omega BC is come outside the screen. Okay. Okay, then you can put in the parameter already lah. Once you find your IC with your ruler, you draw the arrow from the IC to the point, IC to the point, label accordingly. The arrow is pointing from IC to C, so you write RC stroke IC. IC is from this one. This one is what? RB stroke IC. Okay. So this exercise is to show you how to draw the IC point. This one, link BC, this one, move this way. This one can move this way. So C and B link, how they move? How they move? If this one move down, it move like that, right? Okay. Important that you know that this one is circular motion. There is a tangent direction. This one also have a circular motion. There is a tangent direction. So you just copy the object, put in the point C and B, copy the rotation pathway, copy halfway. You know this is tangent. This also tangent. And this one is rotate. This one we move down like that. So omega CB will be clockwise. So can you draw the IC point? Again, this is C, right? So of course you can move this one down, right? So move this one down. Pull your ruler. Put here. Draw. Put here. Draw. The answer is infinity. It do not intersect each other. Your R from IC over here or from here is C stroke IC infinity, same with B. As long as do not intersect, the answer is infinity. Okay, so we want to find the omega. What is omega? From the equation V equal to omega R, you rewrite omega equal to C divided by R. How to find this one? You can use either this one or this one because it's the same thing. So VC is here, R VC is here. You divide something with infinity. What is the answer? 0. If you infinity on top is unsolvable. Okay. So that's why there's no move, there's no rotation in this member. Okay. So the rest you read lah. Same with here. Block D, move speed here. Block D, move here. So when this move here, this one will move like that, this one will move down. Determine angular velocity of link BD and AB at the instant stroke. You need to find angular velocity, which is omega, okay, of link A and B. So you need to split them into two bodies, but same method. So you look at BD first. You draw BD. Sorry, BD is BD like that. This is D. This is B. So D move this way. B, how B move? Like that, right? So B will move that way. Then AB. How's A move? Does A move? A doesn't move. So no velocity there. So we do A and B, BD. So BD is perpendicular, tangent direction to this one, right? Then D, again, use your ruler. Put to D, put to B, you should able to find intersection point, right? So B is here, pull here 90 degree, D, pull 90 degree, right IC, then which arrow always point IC to the point, IC to the point, right RB stroke IC, RD stroke IC, okay? Then it asks you to find angular velocity, right? Recall what is velocity equal to omega R. You want to find omega equal to VR. So just read what you can hear. So either you use this one or this one, you will get the same omega. Same. Okay. So, but there's an angle there. All right. There's an angle there. So just be careful. So the length is 0.4, angle is 45. So you need to find, you can find the RB stroke C there. RB stroke C, you have 45. You have right angle here. It's a right angle triangular. You have the distance. So RBC, you can find is 0.4. Okay. Then you can find RB stroke IC is 0.5 something. Then you put in the equation. Omega equal to V divided by R. Substitute, you get something radian per second. Yeah. So the important part is you know how to draw the IC, how to find the IC. And some question is a very stupid question. Some is like the one in example 7, give you infinity one. The answer is 0. Okay. So sometime test 2 will try to help you, give you very stupid question. The answer at the end is 0. Like example 7 just now. So but you still need to write the equation. You still need to write omega equal to V divided by R. Then prove that omega is 0. Yeah. So velocity, once you have the omega, you can find the VB, the R. So again, try to link the correct one. VB and VD is a different. VB, you need to use this set. Don't use the wrong set. So VB equal to omega. Omega is the same for B and D because the same rotation. But the velocity will be different. Velocity equal to R. Is R by this one. So you substitute the value, you find VB in a 45 degree from the horizontal. Uh, so what about AB? Still same process. You find where is your IC. So here, omega equal to V divided by R A stroke B. Okay, in this case, you don't need IC. You can straight away find omega. Right? VB you have. RB stroke A you have. Substitute. The value is 5 point something and clockwise. Yeah. Relative motion, this one is acceleration. It's the same. When you talk about acceleration, it's the time differentiation of velocity. Right? So same, we introduce you VB equal to VA plus VB stroke A. When you want to find acceleration, you time differentiate the velocity equation. You get like one you see on the screen here. So you get VA equal to VA plus VB stroke A. Again, I need to highlight when you have B stroke A, because you have a rotation and circular, you need to split into normal and tangent direction. Why? Because now dealing with angular velocity. Angular, they should have a rotation. So rotation normally is a circular motion. Okay, so this one already explained like how to general plane, how it consists of translation and rotation. Okay, so this one you read lah. So if rod AB rotate like that, equal to translate plus rotate. Okay, then you draw the diagram here. Okay. Okay. Now this one. This one, there's a negative sign there. Why there's a negative? Because the normal and the radial is different direction. Huh? Okay. So BA in a normal direction, acceleration in normal direction is negative because your positive radius is going out. Positive direction of your radial R is positive. So when you want to combine the normal direction, you get negative. Huh? Okay. So just be careful lah on this side. This is vector approach. Huh? This one you read. So when there is a disc rolling on the floor, velocity at A is 0. When there's a rolling body and rolling body always touching on one point only at certain time. So velocity at A always 0. When you have a round bodies with the rotation, angular motion, your velocity at A at that point will be 0. Huh? So you switch to kinematic diagram. If this one rotate in the center of gravity, what you're seeing here when this roll, center of gravity actually moving to the right. So you have Vg to the right. Then from A is always refer to G, right? From the G location refer to A. So you write Rg stroke A pointing inside. So when you want to calculate the velocity of G, what you do? You need to take Vg equal to Va plus omega cross Vg stroke A. This is a vector analysis. Huh? What does it mean? This one. Okay, so this one is a relative, right? So relative G stroke A, you write R G minus RA. Change this one to velocity. You want to find velocity of this one. So Vg equal to Va plus Vg stroke A. How to find Vg? This one you change this one to omega R. Okay. The R here is G stroke A. Yeah, it's the same thing. But this one is vector form lah. Vector form. Okay. But to simplify, you just need to remember velocity equal to omega R. Okay. Then you time differentiate, you become acceleration. Acceleration equal to alpha R. Same like what we write on the whiteboard here. Okay. Acceleration, you have two components, normal and tangent. Acceleration tangent is alpha R, normal is omega square R. In this case, tangent direction of A or G will be alpha R. Huh? Okay. So I think we stop here. Right, we stop here. We continue this one. Huh? Okay. Example 9, I treat it as your Amela. We come back to example 9 next lecture. Okay.